Good day, everyone. I'm Brennan Lafferty, publisher of Plastics News. Welcome to Ask the Expert, our new live stream series. With Ask the Expert, this is your chance to engage with professionals to address the current business environment, to discuss some best practices, and most importantly, to ask some questions. This week's topic, improving operations. And we have 6 live streams scheduled this week on various operations issues. Today's topic is a new solution for injection molders, the Shuttle mold system. Our expert today, Canon Virginia. Representing Canon is Director of Business Development, Wayne Daniel. Now, Wayne will answer your questions after his presentation. But to submit a question, email pnevents@crane.com, or if you're watching the live stream on a social media platform like Facebook or LinkedIn, send your questions through those platforms. With that, I'll turn things over to Wayne Daniel of Canon Virginia. Take it away, Wayne.
Thank you, Brennan. I'd like to thank everyone who's taken their time out for this presentation. Hopefully I can provide some value to you to make it worthwhile. I'll start by giving you a little bit of insight about Canon and a little bit about my background. Next slide. So I'm with Canon Virginia, and yes, we are the same Canon that has all of those cameras, printers, and other Canon products out on the market. Canon Virginia is Canon's only manufacturing facility in North and South America. We're the technical headquarters for Canon in the Americas. With all the products that Canon has produced over the years, we've gained a large knowledge base in manufacturing. This also includes injection molding and tool making. Myself, I've been in injection molding for 30 years. Most of that time has been directly on the molding floor, but also in tool manufacturing. And currently, as Brennan said, I'm serving as the Director of Business Development. And what I'd like to talk to you today about is how innovation and operational efficiency helped us and how it can help you improve your costs. So let's get started with the next slide. So reducing costs, it's the ultimate goal. One of the main challenge and focus areas that I've been heavily involved in over the years is projects related to cost reduction. How can we reduce our costs, and how can we gain an edge, and how can we compete? Just like any other competitor situation, just as soon as we think we've done great work and implemented great ideas, guess what? So is the competition. So it's a never-ending cycle of continuous improvement. The things I want to talk about today impacting costs in our operations are productivity, cycle time, changeover time, space, and inventory. Now, this isn't an all-inclusive list, and I won't focus on material cost or various other costs that go into our roll-up of fixed and variable costs. I want to talk about part process cost. So let's go to the next slide. So these are the 5 items that Canon targeted when we set out to reduce the cost of our in-house injection molded inkjet printer parts. So let's talk about each one of these quickly. So productivity. Let's look at productivity from a molder's point of view. If your machine runs all day at its intended cycle time without stopping, we consider that productive. But is it really? How many hours of the day is that machine really truly working? In most cases, a molded machine is only productive about 50 to 60% of the time, because after injection, pack, and hold, cooling time starts. And during that time, the machine is sitting idle. But what if you could get that time back? How much could you save on a daily, weekly, or over the course of a year basis? So the solution to your productivity issues on molding equipment is to turn cooling time into production time. This reduces the idle time the machine has and increases output. Let's talk about cycle time. Just like any molder, Canon has always tried to optimize cycle time. Cooling is typically half to 2/3 of the overall cycle time. And there's a lot of things that can be done to improve cooling time, and a lot of this is done up front during the design process, designed for manufacturing. But in the end, though, it seems like every part has its own unique challenges and its own reasons why the cycle can go no lower. So if we can't reduce that cycle time, how can we make it work for us? You can increase part production without reducing cycle time. Changeovers. If you have more molds than you have machines, then chances are you're doing changeovers. But how many do you do per day? And how long does it take? And how much time do you spend just in changeover? We run some quantity of parts, change over to another mold, run some quantity, and repeat that process over and over again. And we lose time every time. So the solution to your changeover issues is to automate your changeovers, reduce your downtime, and eliminate human errors. Because with changeovers, we rely on our people to do that. And as good as they may be, it opens us up for risk of having something go wrong during the changeover. Space. Most of us don't have unlimited space. What if you could increase your productivity in your current space? What if you could cancel your next machine purchase and use that capital to invest in something else, such as beside the press automation or something of that nature? That sounds like a win-win. So the solution to this, if you have a space problem, is to increase your productivity in the current space that you have. Inventory. Do you try to adhere to lean principles? In a lean manufacturing environment, inventory screams waste. There's waste in stagnation, waste in storage, waste in movement, and then along with that, there's also carrying costs and the risk of having a quality issue that can go back into thousands of pieces of inventory. One answer to that problem could just be to produce a small quantity that you need, change over and produce another small quantity. What if I told you that ideally you need to produce one part, change your tool, and produce the other part, and repeat that pattern all day? That sounds a little bit crazy, but in a lean environment, that is the ultimate goal. So things that Canon has done to tackle these issues created a solution that we're offering now to the outside market. So let's go to the next slide. So I'm going to introduce Canon's solution. It's called the Shuttle mold system. It helped us focus and solve those 5 problems that I just mentioned. And just like other molders, we felt like we had reached kind of the ceiling on what we can do from process improvement and innovation and cycle time reduction. We had to think about how could we take this to the next level and try to innovate a pretty locked in molding process where things have to happen in a certain order. So we looked at it from a little bit different way, and from this, the Shuttle mold system was developed. And Shuttle mold was first introduced at NPE in 2018 just as a demonstration of Canon's technology. The system generated so much interest that we decided to offer this to the outside world. And what exactly is Shuttle mold? Shuttle mold is an add-on shuttle system that allows us to use the cycle's cooling time more effectively by simultaneously running 2 molds at the same time. The overall goal is to keep the machine working, and we do that by utilizing one part's cooling time to fill and pack another part. And because we can simultaneously run 2 molds at the same time, the available capacity and productivity of the molding machine goes up significantly. So I'll show you in a moment a side-by-side comparison comparing a traditional single mold, single machine method and a machine running shuttle mold. And the main key point is to note is the amount of work being done by each machine. So let's go to the next slide and start the comparison. So on this comparison, on the left-hand side of the screen is your traditional single mold, single machine method, and on the right is shuttle mold. If you look at the spinning blue pie chart on the left, you can see that the cooling time, the light blue area of the chart, is about 2/3 of the overall cycle. During this time, the machine is basically just sitting idle with the part in the mold. But if you look at the shuttle mold system, look at the pie charts there. We're doing something during that cooling time. Essentially, we're filling and packing another part. And since the system takes advantage of each part's cooling time, it's important to have enough time to work with. If there is, productivity can be increased. You can obviously see that the output was greater on the shuttle mold method versus the single machine method. Also, to note, we were molding 2 different parts, a square one and a round one in this example. The reason for that is because with the 2 molds, We can independently control each process condition separately. Let's go to the next slide. So the shuttle mold system has shown Canon how much of an impact we can make in a molding operation if we change the way that we think about something. I want to go over a quick summary of some of the applications that's best suited for this system. So for cycle time, to really get the benefit, we target cycle times of 30 seconds or greater. So as I mentioned, there has to be enough available time or wasted time in the process to fill and pack another part. Cycle times within 30 to 40 seconds do require special study in order to make sure we can get the productivity level that we desire. But anything over that is pretty much, there's enough available time to do something else. For industries, so this system is not industry specific, it's application specific. So some good examples are large parts that have thick walls, longer cooling times, things of that nature. Materials, the current system is used on most commodity grade thermoplastics. And tolerances. So because we release the clamp on the mold after holding, we do have to worry a little bit about tolerances, but we haven't had any trouble hitting anywhere from 0.01 millimeters to a half a thou in tolerance ranges. For machine size, so our current offering covers 230 to 680 ton metric size machines, or 250 to 700 ton US, as standard systems. There is larger and smaller systems available with custom designs. And then, of course, for future development, we're expanding the capability of the system to use with engineering grade resins, high tolerance, tight tolerance parts, and also expanding the line to up to 1,000-ton machines. So as I mentioned, larger parts, thick walls, longer cooling times are where this system has benefited. So we want to go up to 1,000-ton size. And next slide. And that concludes my presentation. I'll turn it back over to you, Brennan, for questions and answers.
Wonderful. Well, great job, Wayne. Great information. As he said, we are going to take our questions now. As a reminder, to submit a question to Wayne, simply email pnevents@crane.com or submit your questions through the social media platforms you might be viewing this on, and we will get those questions right to Wayne. All right, Wayne, we do have several questions lining up here. The first one, do the water lines stay connected to the dies in the shuttle mold system?
Yes, so each independent mold has its own water line connections, hydraulic connections, electrical connections. All of those stay connected during the shuttling function. So really the only requirement is that the tubing, hosing, cables need to be flexible because we are sliding in and out. But there's no need to disconnect.
Okay. All right. Once the shuttle mold system is installed, can I run the machine like a normal machine?
Yes, the shuttle mold function can be turned off and your machine can be used as a standard, traditional, typical molding machine. Yes.
And, related to that, Wayne, we saw the diagram, the moving diagram. What kind of space or real estate does the shuttle mold system occupy, or do they come in varying sizes?
So the overall size really depends on the machine size itself and tonnage. So the system will be sized to that machine. I can't really throw out a number because it is dependent on the machine tonnage.
Yeah.
But it is significantly less space than two molded machines side by side, for example.
Yeah, for sure, no doubt. Okay. So questions coming in here. Can I use the shuttle mold system with an existing machine or mold, or do I need to start new?
The system can be used on existing equipment. So obviously the cleanest way to do it is start all new with everything. However, it is an add-on system, so it can be added on to your existing machines. As long as that machine is not so old that it cannot be upgraded with software. So a machine from, say, the 60s or 70s may not be a good candidate for that. Right. But as long as your manufacturer of the machine can upgrade the software, it can be added. And the tooling, really the only requirements for the tooling is that being we use guided roll-in system, and location and clamping. The overall structure of the tool, the clamp plate or mold base, may need to be modified for a certain size. And then possibly your connections relocated from the bottom of the tool, for example, to the sides.
Right. Okay. All right. So we won't be hooking the shuttle mold system up to the system machine from the 1950s or 60s, but
That's probably not a good idea.
makes sense. All right. So Wayne, here's a question in from LinkedIn. Can we use two different color dyes for two different parts in the shuttle mold system? I was wondering that myself.
So the short answer is no, not currently. So one of the requirements is being we're using a traditional machine, single injection unit, both parts need to be the same material
Hmm.
at this point. However, we are in discussions for future development to incorporate, multi-shot or, two-shot type systems. But currently that is not an option, but a future development.
And I think you went over this, but can you talk just maybe one more time? What types of resin is this best working with right now?
So most general purpose commodity thermoplastics, so polyethylene, propylene, polystyrene, ABS, polycarbonate. We actually did a example at K Show with nylon.
Mhm.
So yeah, most general purpose resins.
All right, well, I'm going to make you repeat yourself because a question came in from email. Can the shuttle mold system process POM, PPS, nylons, which you just mentioned, and PPD? Part two of that question, are there any special requirements for these varied materials?
So back to the materials, yeah, most general purpose resins. We have not done POM yet. However, we're looking at that. It's really not a lot different. So um, yes, I think it's very capable of that. We're constantly testing new materials. Now some of the very high temperature engineering materials, we're not there yet. But for most plastics, it's not an issue, and we can discuss if there's any potential issues with that.
Right. I'm sure you'd be happy to, work with anybody.
Absolutely.
Yeah. Okay. Very good.
Anyone can come to us with their application. We'll look at the part size, the cycle times, the materials, and definitely work with them and hopefully be able to provide and simulate what the benefit would be.
Yeah. That makes me wonder, Wayne, in this COVID world that we're in, how are you, demonstrating the product? Are you making arrangements to travel to customers' sites, or are you able to do a lot of the work virtually?
We're trying to do a lot of it virtually with events like this. We did have a unit, there was a demo unit on site, but unfortunately, many companies had travel restrictions and couldn't come. So we're hoping that won't be the case next year. We also have, the large plastic show next year. So hopefully that's doesn't get canceled.
That's right.
But yeah, and whatever we can do virtually through video or infographics on our website and things of that nature is how we're trying to promote.
Yeah. All right. Another question that's come in. What is the maximum mold weight and machine size I can use with this system?
So that's really dependent on the machine size. So the system is really whatever the machine is capable of from a platen weight point of view. The shuttle mold system is designed around that. So it's really up to the machine manufacturer, whatever their maximum weight is, that's the weight that we will go with.
Okay. Can multi-cavity molds be used with the shuttle mold system?
Yes. So it can be anything from a single cavity to multiple cavity. As long as you can mold it in a standard typical machine, we can do the same thing in shuttle mold with multi-cavity molds, including family molds. Like I said, the only really exception right now is both molds need to run the same material because we are only using the single injection unit.
Okay. Yet another question in. Lots of questions. Thank you to everyone sending these in. If the shuttle function is turned off, how is the system used for quick changeovers? You talked about changeovers.
Yes, so that's actually a little side benefit of the system. So if you turn the shuttle off, the function off, and you're using the machine as a typical standard molded machine, the shuttle mold system can actually be used as a quick change unit. So you have everything there from tool staging to water hookups, hot runner hookups, hydraulic hookups. So you can preheat your tool, stage it, preheat it, and get it ready to go, and basically perform the changeover with literally a touch of the button to engage the system. So it's kind of a side benefit of a quick change system along with the shuttle function for production.
Yeah. Okay. Um, the next question is, can the two molds have different shot sizes? That's a good question.
Yes. So as long as the two different shot sizes are within the capability of the injection unit on the machine,
Right.
you can run two complete different volumes because we can independently control both process conditions. So stored in memory of the machine, of course, is the program for mold A and B. The screw will back up to preset shot size for whichever mold you're molding every cycle. And that can be different between a small shot and a large shot as long as it's within the capability of the molding machine.
Okay, that's clear. Wayne, a question from our audience on LinkedIn. How does this system work with a hot runner system?
So there's no difference between using a hot runner system with the shuttle mold system versus a typical machine. The hot runner connections stay connected. The hot runner stays at temperature. And the cycle, you're really only shuttling it out for, 10 seconds or so. So there's no really issue with residence time. As long as the hot runner cable is flexible and long enough and we, keep it from anything happening to it, there's no difference at all.
Okay, good to know. Is the shuttle mold system on the market today? Can I purchase the system, or is it in the demonstration phase right now?
So the system is on the market today. Currently, we are offering systems to handle what I mentioned between 250 ton and 700 ton size. Those systems are available today.
Yeah, good news. Available now. Call Wayne.
Yes.
You may have covered this, but we have another resin question. Do I have to use the same resin for the two different parts when using the shuttle mold system?
Yes. So as I mentioned, we're using the machine's injection unit, just one injection unit. So
yeah,
at this point, same resin, same melt temperature. Future development, we'll look at possibly dual injection or add-on injection units and things of that nature.
Yeah, seems like there's a lot of runway here for this system.
Yes.
Interesting question. We do a lot of work in automotive and medical. What are the best industries for this technology? Which have you had the most success with?
So as I mentioned, it's not industry specific, it's application specific. So looking at medical and automotive separately, automotive would probably be a better application just for the sheer fact that typically the parts are larger and have thicker walls compared to very small medical parts. You're looking at micro parts with some of that. So as long as we can get the cycle time or the amount of cycle time 30 seconds or longer, it's definitely something that we can look at being an application. Anything less than 30 seconds, really there's not enough available time to do anything else. So I'm only saying that just for the fact that automotive tends to have longer cycle times compared to medical, but it could be for any industry. If you have a large medical part with a longer cycle time, absolutely, this is a benefit.
Yeah, there certainly are those processors out there that do make large pieces of equipment in the medical space. So that would be a good fit.
Yes.
All right, Wayne. Okay, this is interesting. What type of training is needed for learning how to operate the shuttle mold system? How long does the training take? The assumption here being that Canon would help supply that training?
Yes. So the integration is actually done by the machine manufacturer. So we provide the shuttle mold system and some software. The manufacturer does the integration. The machine manufacturer is actually going to be the main contact for the training. Just like when you purchase a new machine, they'll come out and spend 2 or 3 days or however long it is at the machine set up doing the training. So this will also be done by them. Support and everything is provided by Canon also. So it's definitely a good collaboration effort to get you up and running. And then from there, the machine manufacturer usually takes over.
Very good. All right. Well, thanks to everybody for sending those questions in. Wayne, I think we're out of time, but do you have any parting words of advice or final comments you'd like to make?
Mainly that this system kind of challenges the overall injection molding process, so it's not as status quo as what we thought it was. We're not locked in. It opens up a window of quite a few opportunities of things that we can do, whether that's using this cooling time or doing secondary operations down to eliminate downstream processes. We're actually continuously learning the different things that the system can do when you have two molds working together at the same time. And also it kind of challenges the thinking of cooling time and cycle time. So maybe it's actually beneficial now to increase your cycle time as opposed to decreasing it. I mean, what if you increase your cycle time by 5 seconds versus reduced it by 3 seconds, but you increase your productivity by 180%? It's definitely a different way to look at things now. So,
yeah, you're really flipping the paradigm there when people think of cycle time.
Yes.
Indeed. Well, Wayne, thank you so much for sharing your insights today. For those of you watching, if you want to reach out to Wayne directly, you can email him at the address you're seeing on the screen, and I know he would love to talk to you.
Absolutely.
So my thanks again to our expert, Wayne Daniel of Canon Virginia. My thanks to you for joining us today for Ask the Expert. Our Improving Operations series continues tomorrow at noon. Our topic tomorrow, 3D printed tooling. Our expert, Ben Arnold from Fortify. Until then, have a great day. I'm Brennan Lafferty. Thanks for watching Ask the Expert with Plastics News. Stay tuned for a parting message from Canon Virginia.
For 30 years, Canon Virginia Incorporated has excelled as the American manufacturing center for Canon products. Today, that excellence is available outside the Canon family, which means that now, with CVI as a custom manufacturing partner, you have full access to the substantial resources of one of the world's most trusted brands. From concept to market, Canon Virginia Incorporated is uniquely qualified to provide a consistent, high-quality finished product that can be marketed with pride and confidence.